This video explores some new features for investigating datasets in AFNI and SUMA, which could be useful for layer fMRI. These include new SUMA clipping plane functionality, as well as the surf layers and QuickSpec SL scripts we demonstrate across 3 datasets. The first example is from a 3 Tesla auditory and visual dataset used in AFNI boot camps. It's not a laminar acquisition, but we can explore much new functionality. The contrast is visual minus auditory. In SUMA, we see the peel surface, but note we've also run surf layers to make 2 equidistant surfaces between this and the white matter. If I start the GUIs talking, SUMA sends the surfaces to AFNI, and AFNI sends the stats to SUMA. Starting SUMA's clipping plane mode, a clipping plane is created, which I can move, I can rotate and tilt. I can move the whole brain, and you can see into the cortical ribbon, turning it off and on. Up to 6 of these can be made. Same data in contrast, but now I've extracted the auditory cortex from a free surfer atlas and run surf layers on that surface patch. Where I click in SUMA is linked in AFNI. If I hide a patch layer and click again, I move into the middle of the cortex. This second dataset at 7 Tesla shows left-hand finger tapping with an accelerated Grace pulse sequence. We're zoomed into primary motor cortex, but it's hard to see into the surface sulcus. Of course, we could use clipping planes, and we could look that way. Or we can use Surf Smooth to inflate the surfaces, followed by QuickSpec SL to create a spec file of the relationships. Now, we can see surfaces and into surfaces in SUMA more easily, and we can hop through. Note here we're at pink. If I hop through and I click again, now we're at yellow, and I hop through again, we're stepping deeper and deeper into the cortical ribbon. Finally, a retinotopic dataset at 7T with the contrast vertical minus horizontal wedges. This shows a patch of the calcarine sulcus that was drawn onto activations projected on a spherical surface. With patches, we can use clipping planes to trim the boundaries, like that. But surf layers can create any number of intermediate surfaces. If we make, say, 20, the effect of this surface upsampling shows the voxels quite accurately. AFNI's always tried to help users stay close to their data. We hope these tools enable a unique ability to explore cortical layers and depth-dependent activation across the brain.